Good evening, everyone. In this video, we'll be talking about signal generalization. We already have seen class level generalization. Okay, so we have seen how classes were actually inheriting the attributes and features. Okay, so different features. So basically, the attributes and methods. Okay, so in some sort of hierarchy. Okay, so that's about the generalization. So we can also organize signals into a generalization hierarchy. Okay, with inheritance of signal attributes. We already have discussed signals and signal events, okay, in one of the earlier videos. Okay, so the basic idea is say for example flight A1 to 3 leaving Hyderabad. Okay, say for example that is a signal. A flight departing, okay, is an event signal. Okay, so basically it will have the time, it will have the destination. Okay, so basically from which location etc. will be there. And the signal event is happening of one of the signals. We have already discussed. So the signals can actually can be analyzed. Organized in this generalization hierarchy. Okay. So let us see. Say for example, let's see an example. Okay, where we are seeing a partial tree of input signals for a workstation. Okay. Let's first see that example so you will understand it better. So you can see there are different signals here. So the user input. Okay, so which will have an attribute of device. Okay. So that's one signal. And then it is actually being, the generalization. So basically there are two different signals which are mouse button and then keyboard character. Okay, user input can be with the mouse or with the keyboard. Okay, so both these things actually, both these signals actually inherit the device attribute. Okay, they themselves have the attribute. Say for example, mouse button has this location as the attribute. Okay, and then this keyboard character has this sort of whatever character which you have pressing. Okay, so that has the attribute. Okay, those are the signals there. Then if you think in terms of the mouse button signal, okay, so mouse button down and mouse button up, both will be two different signals, and these are actually inheriting from this mouse button. And in that sense, they basically inherit this location attribute. Okay, both of them will have the location attribute, both these signals. In the same lane, say for example, this keyboard character. The keyboard character signal can be either it can be a control signal. So for example, control, shift, and those things. Okay, it can be a control signal or it can be a graphical signal, which you actually type. Okay, and the graphic signal can actually be inherited. Say for example, the generalization hierarchy can be for this sort of space. Okay, the space button is there. Okay, and it can be alphanumeric character here. Okay, so any of these alphanumeric characters on my keyboard. Okay, alternatively it can be the punctuation. So pressing any of these input actually will generate a signal. Okay, so it can be an alphanumeric character, but then eventually it's also a graphic and also it is a keyboard character. So in a state diagram, a received signal actually triggers the transitions that are defined for any ancestor signal type. So that means by typing an A would trigger the transition on signal alphanumeric input, as well as signal graphic as well as signal keyboard character. So if I'm typing an A, so we are triggering both this one, this one, this one. So a complete hierarchy you are actually triggering. Okay, so that's what we are saying in a state diagram. A received signal triggers transitions that are actually defined for any ancestor signal type. Okay, that's about signal generalization. Why do we actually use this signal generalization? Okay, so actually a signal hierarchy permits different level of abstraction to be used in a model. Okay, that is the main advantage. So we can have different levels of abstraction. Okay, some states might handle all input characters the same. Okay, whatever you type, some state might handle it the same, and some other state might treat control signals differently and printing characters differently. Okay, it all depends on the abstraction, the way you are actually trying to model that particular application. And there can be some other states which actually might have different activities for even every individual character that which you type. Okay, so that's the sort of signal generalization. Okay. So regarding the reference is concerned, we are in chapter 6. Okay, of Thank you very much for your attention.